Okay, good afternoon, everybody. My name is Shawn Moorgas, and thanks for the opportunity to present at the National Siltation Symposium. Today, our talk will cover one of the sub-projects that is run by the Department of Water Affairs and Sanitation in efforts to improve national siltation management and strategy for dams in South Africa. So today, I'm going to be co-presenting with my colleague, Louise Lodenkemper, who's from Zutari. And in terms of our roadmap, we're going to look at a bit of the project introduction, the project aims and objectives, the project team, where we are now, what does reading the landscape mean, and the key role players in the dam siltation management, and a bit on the way forward. So our presentation covers an aspect on which we are thinking a bit innovatively and out of the box in terms of siltation management within South Africa. So in terms of the problem statement, we all know that in general, siltation management is an issue within dams, and it leads to the loss of storage as well as other resource impacts upstream and downstream, and also has been accelerated by climate change and also human activities. So there's an increased interest in using dredging to solve the water security problems, but we need to think a little bit innovatively, and we need a strategy to see when it's appropriate to dredge and when is it not appropriate to dredge, and what are the solutions other than dredging that we can look at. So sedimentation is really an aspect in terms of significant water quality problem in South Africa. And the main strategy for assessing the problem at the national scale has been through the sedimentation heel map. And the map that you're seeing right now is the one that was done in 2010. But the problem has not been since then. It's been ongoing for some time now. And it's not only a national problem, but a global problem. But there are other methods of actually looking at seeing what the sedimentation heels are around the country. So in terms of our national siltation program, the Department of Water and Sanitation, together with WRC, launched 4 specific projects, and they called some projects to the National Siltation Program. And we form part of the first project, which is the Siltation Management Strategy. And I'll speak to that a little bit now, but there's another 3 projects which feed into our system in terms of determining that strategy for the implementation phase. So there's an SP2, which is the Dam Engineering and Socio-Ecological Systems, and then also the sustainable dredging of dams, and the training and capacity development. And in each of these 4 projects, we are thinking about innovative solutions to addressing the siltation management of dams within South Africa. So when we look at the sub-project, our strategic focus aims to develop an implementable strategy to prevent and manage the siltation of dams, as well as to stimulate local economies and cost recovery. Now, I must mention that this is a phased approach that the department is taking, and these 4 projects form part of the first phase. But within our project itself, our project is divided up into 2. An assessment and engagement phase, which we are busy at the moment, and then, of course, the development of the strategy, and also the implementation planning framework, which will assist in the implementation going forward, together with strategic M&E and risk management frameworks with supporting tools. Once that is done, and we have the involvement of everybody on the strategy, we can then create the necessary platform to implement the dam siltation management strategy and implementation framework. So the activities around the actual project itself, you can see there's an inception phase, like I mentioned, the situational analysis, and then actually the final drafting of the strategy and implementation plan. And you can see the deliverables that are associated with that and what feed into that final plan. And also, very importantly, the workshops that we're going to be having with the general stakeholders in the different elements, which Louise will capture a little bit later. So in terms of our project team, we've got a diverse team with a lot of skills and knowledge within the sector. And there are 4 companies which form part of these sub-project 1. Imanti Management, Zutari, ASP Tech, and Econologic. And Zutari, ASP Tech, and Econologic are also involved in some of the other sub-projects, which makes alignment with the different projects more efficient and is well needed for this project, as all three of the latter projects that I mentioned earlier feed into the dam siltation management strategy and implementation framework.
Thanks, Shawn. So where are we now? Currently, we are considering the fundamental principles of how we're developing this strategy, and it's based on the concept of reading the landscape, which is essentially a simple conceptual way of going beyond the dam and viewing it in the context of its wider system. There are also other issues that we want to try and address, like keeping the strategy simple, practical, and achievable, and needing to engage key stakeholders and looking at supporting local economic development with co-benefits. And next, the strategy and plan framework then moves from a situational assessment, as Shawn mentioned, to the planning phase, where we'll be looking at the strategy and the plan. And before stakeholders can then co-manage dams and the catchments together. Currently, we are on the situational phase, and we're moving into the planning phase, where we'll be running workshops to define the vision and defining the key strategic areas for the strategy. Okay, but now let's focusing on what reading the landscape means. The intention behind this is characterizing the catchment of a dam to be able to identify the relevant indicators which have been shown to have an impact on not only the erosive potential of a catchment, but also on the capability of that eroded sediment to reach the dam in large quantities. And this concept of reading the landscape allows one to foresee the sediment generation potential of a catchment and thus derive generalized recommendations about the spatial and temporal scale of management options. Now, to go into a bit more detail about that, looking at what a catchment is, it's a fluvial system that is linked internally by a network of channels, and these contain both topographical and hydrological systems, which are fundamental spatial units of a landscape. And we're using this concept to help us define the catchment in space. And the catchment boundary defines the separation of surface flow between these hydrological systems, and is usually demarcated by a ridgeline. According to Roundtree and Wadeson, the catchment can be defined as a land surface which contributes water and sediment to any given stream network. Then looking at the main components of a sedimentation process that can be represented across different spatial scales of a fluvial system, we then can define the characteristics of a sediment source, i.e. the dam's catchment, the characteristic of sediment transfer, the transfer or the transportation of sediment to the sink, and then the characteristics of a sediment sink, i.e. where the dam wall and its storage reservoir are, as well as where there's other sediment deposition areas, for instance, estuaries or downstream ecosystems. And that's just a nice spatial layout for our understanding of how sediment moves through a landscape. The next is to then conceptualize how sedimentation is being controlled in space and time. Just looking at it from a space perspective, all landscapes do naturally adjust and evolve over time, but the importance for sedimentation management is to explain those controls and driving process interactions and how they've changed or adjusted over time, and interpreting what has triggered these changes and the differing controls of landscape behavior that operate over variable spatial and temporal scales. For instance, the valley setting, the slope and width of a valley is a primary determinant of imposed boundary conditions that have already been set many years ago, and geological features such as the tectonic setting, the lithology, or any topography that might affect the erodibility and erosivity of a landscape. So those are also considered to be long-term features, and climatic factors that influence the nature and rate of sediment moving flood events. And in terms of reading the landscape, it's also critical to have that conceptualization of time, because catchment controls act over different time frames, ranging from millennia in terms of those geological controls to individual flood events. And a management timeframe is usually focused on static time, so where change happens around a mean condition, with no discernible large-scale erosion of the landscape. But when considering changes to the sediment regime at a catchment scale, it's likely that the changes will only be noticed over more dynamic or geomorphic time. Therefore, the management time frame of static time is not always appropriate. So we just have to really be aware of how any interventions we apply in the landscape will take a while to actually be seen in the sediment yield reduction. Then looking at the cause and effect system map, you get an understanding of the different controls happening in the source, transfer, and sink zones. The main impacts of in the source zones are the removal of vegetation cover through land use impacts, which exposes the soil and accelerates sheet and rill erosion. And the eroded sediment then moves through the transfer zone more quickly. And depending on if there are gullies connecting the upper catchments with channels, sediment is transported to the dam or the sink zone, where it deposits and leads to zone sedimentation. And the effects of that would be this removal of vegetation cover and exposure of soil increases runoff and reduces soil fertility, as well as having human and biodiversity impacts in the source zone. Then in the transfer zone, there'd be increased floods, gully or stream erosion, and other biodiversity threats. At the dam, the effects would be on water security and water quality degradation, as well as any downstream impacts to ecosystems that require the sediment. Then the interventions that have then been proposed to deal with these causes and manage sedimentation are orientated around improving vegetation cover and reducing rill erosion in the source zones, reducing gully and riverbank erosion and trapping sediments just upstream of the dam in the transfer zone. And in the sink zone, sediments would be routed or removed, or there might be some adaptive strategy planned. Then there are quite a few intervention options that are available to achieve these objectives. And the most appropriate and cost-effective is being reviewed under sub-project 2. So there's quite a lot of background there. Now then, looking at the key role players in dam siltation management, there's 5 key role players that we have identified, that being a dam owner or operator, catchment manager, environmental managers, land managers, and mining environmental managers. The key stakeholders we've then defined in each of these zones, because they would have different objectives, mandates, or interests. And those range from water resources to environmental to land management interests. For a dam owner or operator, their considerations will mainly be oriented around what's happening in the dam and the siltation impacts. And the role will typically be with the DWS, but they might also include privately or municipally owned dams. And the cause and effects, or the main issues, as I said, would be the water resource depletion and degradation, and you would really just be focusing on the dam itself. Then when you're looking at the rest of the catchment, the considerations would be around issues of climatic or land use impacts and land ownership in the source zone, the connectivity in the transfer zones, and whether there are any downstream ecosystems that need sediment in their release under the reserve. And this role will typically be the catchment management agency, but could also be a dam owner or a land owner looking at catchment management. And then considering the cause of and effect of each of these zones indicates that catchment management would need to be aware of most activities causing in most of these zones, as well as the siltation issues on site at the dam. Then for the environmental manager, considerations when looking in a dam's catchment would be around issues of alien invasive plants, whether there's overgrazing, and what the fire regime is in the source zone, as well as gully encroachment and cultivation in wetlands, which are considered critical ecosystems in the transfer zone, and downstream ecosystems that are impacted by the interventions in the dam or the sink zone. The role would typically be Department of Forestry, Fisheries and Environment, but could also be other environmental agencies and provincial agencies, for instance, Cape Nature. And the consideration of cause and effects in each of these zones would mainly be orientated around removing of vegetation cover through overgrazing and deforestation. And then that would obviously expose soil, but also need to be aware of increased intensity of rainfall and the landscape's existing considerations. And then the cultivation of grazed stream banks or wetlands, which would initiate gully erosion or riverbank erosion, which would connect the catchments with the channels and move quickly through a catchment and result in dam sedimentation. And then the effects that the environmental manager would mostly be focused on would be threats to biodiversity, human habitat degradation, as well as threats to fishes and water degradation. Then looking at a land manager, the considerations for concern would be around issues of how erosion is reducing soil fertility, how subsistence farmers are impacted in the source zone, and then in the transfer zone, considering how gullies are encroaching into arable land, and then at the dam or sink zone, understanding how much water is available for irrigation. And this role could typically be the Department of Agriculture, but it could also be a landowner or a municipality or tribal authority who take on this role. Then considering the cause and effects, again, it would probably be expanding across the source, transfer and sink zone and cover most activities. But the considerations for the effects would mainly be orientated around loss of soil fertility, crop yields, food shortages, reduction of income and standard of living. And then in the transfer zone, it would be around floods, gully erosion and stream bank erosion. And then in terms of at the dam, the land manager would mainly be concerned with the degradation of water supply for irrigation purposes. Then from a mining perspective, this is mainly concerned around the release of metals into the river, or if there are any mining activities causing erosion. And then in the transfer zone, whether or not there's been sand mining in the rivers. And then again, in the sink zone, how much water is available for mining. And the cause and effects would then focus on heavy metals and chemicals binding with the sediment and then being trapped in the dams. And also looking at removal of vegetation cover and gully initiation in the transfer zone. Okay, so that's just a bit of a brief overview of how we've considered the stakeholders and the key role players in dam siltation management. The way forward then for the strategy and the implementation plan is we are planning a workshop in June where we are going to, as I mentioned, define the vision and the key strategic areas for the strategy. We are also working on integrating all the previous deliverables into the strategy, which were the conceptual systems map, development of case studies, which we've reviewed, and understanding the community and SME benefits, governance and financing situation. And then our next step will be to develop the implementation plan and associated deliverables. This will all be happening in the next few months, and we're hoping to have a draft strategy and implementation plan ready by the end of the year. Great.